Today we have a foldable on how to convert between the three different forms of a quadratic or a parabola. So to make the foldable, first you have to hot dog your piece of paper. Then we're going to do a trifold because we have three things. You need to cut two slits on the front of the piece of paper and then label them 1, 2, 3 going across the front. On the inside of the flaps you have 4, 5, 6. 7, 8, and 9 are the bottom panels underneath each thing, and then on the back you have slides, panels 10 and 11. So what the panels are is on 1 you have standard form, which is just what we've been working with, polynomial in standard form. It's quadratic trinomial, ax squared plus bx plus c. Might not be a trinomial because some of those can be 0. The next form that you have is vertex form, so that's f of x equals a times x minus h, quantity squared, plus k. And then finally you have factored form, which is f of x equals a times x minus p times x minus q, or if actually p is equal to q, you just write it as f of x equals a times x minus p squared. So working with the first form, which is standard form, the panels underneath that are 4 and 7. It's real easy to see what the y-intercept is with this form because it's just c, or the y-intercept is 0c. It's also easy to see if the parabola opens up, and if it does, it has a min, and if it opens down, it has a max. The x-intercepts are a little tricky. Here's the formula. We'll see more about that in the next unit in May. The axis of symmetry, also not super comprehensible why that's the right formula. We'll get into that later on. And then the vertex, you put in the axis of symmetry point, and then you just plug it into the function to see what the value has to be. Also not super easy to find. So then 5 is actually the first panel for vertex form. So this is the one where you have the h and k. All of a sudden the y-intercept, not so easy. The vertex and whether it opens up or down, still easy, just the same. X-intercepts are now hard, although this minus being underneath the square root tells us that if this is going to work at all, then k is going to have to be a negative number. If k is at all positive, then this is not going to yield a positive number, unless a is negative. So similarly for vertex form, it's actually really easy to find the axis of symmetry in the vertex. So the vertex, because it's vertex form, is just h comma k. So once you have h and k, vertex is super simple. And the axis of symmetry also is pretty easy, because once you have the vertex, it's just whatever that number is, x equals that's a line, and that's your axis of symmetry. The last two panels, 6 and 9, show you all the facts that you need to know about factored form. So y-intercept also not super clear. You can plug in 0, you get a times p times q, that's not so terrible. You actually see the same numbers, or the same thing for opens up, opens down, has a min or a max. You just need to look at a, so that's common across all three forms, which is really nice. The x-intercepts, interestingly, are super easy to find now because they're just p and 0 and q and 0. You do have to flip the sign from the original equation to get p and q, but that's it. And the axis of symmetry, like we said, anyway, the axis of symmetry, you just take the average of p and q, and that gives you x equals that is the axis of symmetry. And then the vertex is, well, you take that number and you plug it into f, and that'll give you the y value. So here is a diagram on how to convert between forms. This actually goes on number 10. So if you've got standard form and you want to get to factored form, you have to factor, which is we've seen how to do it. It's kind of involved. But going from factored form to standard form is easy. You just multiply. Same thing from vertex form to standard form, you just multiply it out. It's not that hard at all. This completing the square thing, whatever that is, we don't quite know how to do it yet. I'll give you a simple example on panel 11. If you're trying to go directly from vertex form to factored form, I actually have no idea how to do that. It's not really a thing that you can do or that's easy. It's just easier to multiply it out than factor it. Finding the factors is actually really hard. So, but going from factored form to vertex form, right, you have the factors, so you can lean on this idea that a parabola is symmetric. So you just take the average of the two factors, or take their mean, then you get h, and then if you just plug it into the function, you get k. Lastly, we see this procedure for completing the square. So the steps here are you take x squared minus 4x plus 9, and what you're going to do is take the first two terms, x squared and minus 4x, and you're going to put them in a square, because it's called completing the square, and you're actually going to split the negative 4x in half. So this negative 4 is going to become a negative 2x and a negative 2x down here. You leave the 9 kind of alone. Don't need to deal with that at the moment. And then you're just going to factor this out. So you know that both of these terms have an x in common, so you pull it out over here, and then x times x makes x squared, so this has to be an x. And then you ask, well, okay, if this is an x, then what does this number have to be so that you get a minus 2x here? Well, you have to take x times negative 2 to get negative 2x, so these both have to be negative 2's. And then you can take the two negative 2's times each other, you get positive 4 here. But now if you're working in an equation and you all of a sudden add 4, then you have to subtract 4 as well on the outside. So on the left-hand side, you've kind of got this square. It's been quote-unquote completed because we put in this green piece, this plus 4. So you're just going to write it as x minus 2 squared. And then you just simplify the outside. So the minus 4 and the plus 9 becomes 5. So when you're done, you should have a foldable that looks like the following. So you've got your 3 panels on the front with standard vertex and factored form. You flip them open, you have all the facts, standard form here, vertex form, and then factored form. And then on the back, you have this diagram just to remind you how to go between the 3 and this little piece about completing the square. We'll do a lot more of that later.